Hello guys, welcome to Small Samuel Math Tutorials. So the today's lesson will be doing parabola function, which is for grade 11. So the things which we are going to focus on for the parabola functions, for this first video, which is for parabola function lesson, we'll be doing the turning points, the axis of symmetry, the x-intercept and the y-intercept, and lastly we are going to do the domain and range. Then on our second video we are going to do the shifting of the graph, how the graph shift, and then we're going to interpret it, the graph interpretation, and also we're going to do the graphing of parabola, and lastly it will be the methods of finding the equation of the parabola, meaning I'll see how many videos I do for all those topics we have now. So for now, let's focus on the turning points, axis of symmetry, x-intercept and the y-intercept, and also the domain and range. So from parabola functions, we have three equations of parabola functions which we mostly use. The general three general formulas for parabola function, right? Which the first one is, I believe most of us we are familiar to it, which is ax squared plus bx plus c, right? And the second one, which is y is equals to a into x plus p squared plus q. Most people use negative here, and it's not wrong. Most of your teachers they will be using negative, so you can take this one or the one with a negative sign here, right? But it's still the same thing. And then lastly is y is equals to a into x minus m x minus a. So these are our three general formulas for parabola. So we are going to solve the questions which are the turning point, axis of symmetry, x-intercept and the y-intercept, and the domain and range using these three formulas, right? So the first one, and we are going to, don't worry about what is p, what is q, say, and what is m, what is a. I'm going to cover it now. So now let's talk about the turning point. The turning point. Okay, the turning point of parabola. Okay, let's talk about the turning point of parabola. Whenever the question is determine the turning point of the parabola or determine the maximum value, this is the formula which we are going to use. And mostly at grade 11, you won't be asked what is the maximum value or the minimum value. But even though if they can ask you, they want you to calculate the turning point, right? But mostly it's for grade 12, guys. So now just focus on the turning point. What is the turning point? So let's say you are given, okay, we said we're going to focus on the first formula, which is ax squared plus bx plus c, right? Example, let's say you are given y is equals to x squared plus 4x minus 1, right? Plus 4x. Okay, plus 4x minus 1. And then the question says determine the coordinates of the turning point. Right? Remember, whenever they talk about the coordinates of something, they need those two values, which is for the x value and the y value. But then when they can just say determine the turning point, they only need the x value. But then for you to be safe, mostly use find for x and y, right? So how are we going to find x and y? The formula which we are going to use to calculate our turning point is for x value, it's minus b all over 2a, right? And for our y value of the turning point is 4ac minus b squared all over 4a, all over 4a. This is the formula that we are going to use whenever we are asked to calculate the turning points or the coordinates of the turning points, right? So I know like some of you now are busy saying, say, what is B? What is A? What is C? How are we going to calculate it? Okay, guys, don't worry. Like I said, guys, if we can check for the first equation, we have y is equals to ax squared plus bx plus c. Now we are given x squared plus 4x minus 1. So always know that the coefficient of x squared is equals to a, or it represented by a, right? And the coefficient of 4 it represented by what? By b. And lastly, the constant number, which here it's -1, not 1, guys. Whenever they say write down the constant number, you take it with its sign, which is -1. It represented by what? By c. So mean if you can check for the first one, which is ax squared plus bx plus c, where there is a, now from our example is 1, where there was b, now from our example is what? It's 4. Where there was c, now from our example it's -1, right? So we are going to plug them there from the formula that we have for the turning point. Okay, let's do it. Therefore we have minus, what is b? We can see that b is the coefficient of x, which is what? Which is 4 all over 2 into what is a? We know that a is the coefficient of x squared, which here is what? It's 1, right? Therefore then we have 4 into what is a? We saw that a is the coefficient of x squared, and then c is the constant number, which is what? -1, not 1. We take it with its sign. Then minus into, it's very important to write into or add this open bracket for b squared. Therefore our b, we can say that it's 4 close bracket squared all over 4 into our a, obviously we said is the coefficient of x squared, which is 1, right? So meaning now our answer is going to be, if you can press your calculator, you're going to get -2 and -5, right? Therefore we now calculated the coordinates of the turning point, right? So again guys, sometimes, or you can use this formula after finding, okay, let me do a space here because I don't have enough space. Just want to show you this. Okay, yeah, okay. After finding, let's say you don't want to use this formula of minus b all over 2a 4ac minus b squared all over 4a. You think like, no, so I'm going to forget it. Okay, now remember the first step, which is x is equals, you can use this formula, x is equals to minus b all over 2a. This is the second method, guys, which x is equals to minus b all over 2a. And when we calculated that, we found that it's minus 4 all over 2 into a, which gave us what? It gave us negative 2. Therefore, after finding the x value of the turning point, what you are going to do, you are going to replace it. Where you see x, you're going to replace it with what? The negative 2, right? So from what? From our original formula, which is y is equals to x squared plus 4x minus 1, right? So now we're going to replace it. Therefore, we're going to have negative 2 into 2 squared plus 4 into 2 minus 1. And your final answer is going to be negative 5, guys. So it is still the same. So you choose which one do you want to use. Whether you want to use 4ac minus b squared all over 4a. If you did forget about this formula, guys, use this second method, whereby you are going to find your x value, the x coordinate of the turning point. And we found that our x coordinate of the turning point is what? It's negative 2, right? Therefore, after finding the x coordinate of the turning point, we are going to, where we see x, we are going to replace it with what? Negative 2, to find what? To find our y value, the coordinate of the turning point of what? Of the y value, which is negative 5, right, guys? So meaning you're going to plug that x value of yours, which is the x coordinate of the turning point, from your original equation or from your original formula, and then after you calculate. So the answer will be the same, and obviously we can see that we also have minus 2 and negative 5 here, right? So we are done calculating the turning points using the first formula, which y is equals to ax squared plus bx plus c. So now let's talk about the second one, which is y is equals to a into x plus p squared plus q. I know that you are surprised. Say, what is that? Remember from the first formula, which y is equals to ax squared plus bx plus c, if you can complete the square, you're going to find something like this, right? So meaning this format, which is our formula, it's written in completing the square, right, format. So what is p, what is q, right? For p, guys, okay, p represent, never mind my handwriting, guys, yeah, p represent the x coordinate, represent the x coordinate of the turning point. T represent the x coordinate of the turning point, right? P, I mean, guys. And also P represent the value of the axis of symmetry. Meaning our P also represent the value of the axis of symmetry, right? We're going to talk about the axis of symmetry later. So now we're busy with the turning points, right? So what is Q? what is q, what is q, what is q, right? Okay guys, q for now, let's see, let's not talk about it a lot, but then just know that q represent, just know that q represent the y coordinate, q represent the y coordinate of the turning point. Meaning if you have let's say the value of p and the value of q, you already know your turning points, the coordinates of the turning points, right? So now here's the equation. Let's say we have example. Okay, remember we're still on the turning point, guys. Remember, we're still on the turning point. So let's say we're now given y is equals to a let's say a into x plus 2 into squared minus 5, right? This equation, guys, this equation which you see here, if you can complete the square using this one, which is ax squared plus 4x minus 1, you are going to find these values here, which are written like this, right? So now, from what I wrote here, that p represent the x coordinate, and if we can check here, our p is here, which is 2, and then our q, which is here, which is negative 5. But then whenever we write the coordinates of the turning point, it's going to be, if it's x plus 2, guys, you're going to say, you can write x plus 2 is equals to 0, and then solve for x. Therefore our x is going to be negative 2, meaning our x value of the turning point is negative 2, not 2, right? And then our y value, we take it the way it is with its sign, which is negative 5, guys. Then you are done. So meaning for negative 2, whenever it's x plus, let's say if it was x minus 4, let's say if it was, okay, let's say if it was x minus 4, meaning whenever we write it down, let's say if, whenever we write it from the coordinates, or we write it as the axis of symmetry, we are going to solve for x, which is x minus 4 is equals to 0. Therefore our x is going to be what? 4, right? You see it? So meaning whenever you have x plus 2, whenever let's say they want you to calculate or write down the axis of the turning points, if it's x plus 2, it's going to change the sign. If it was positive, therefore it was going to be negative. Now it's going to be negative. If it was negative, then it's going to be positive. And but then for q, the q doesn't change. Q doesn't change, guys. So for q, don't worry. Q stays the way it is. It doesn't change. You take it with its sign. If it's negative 4, you just write negative 4. If it's negative 5, you just write negative 5. If it's 4, you write 4. That's it, right? So now we saw that, okay, finding the coordinates of the turning point whenever we have completed the square, our values are very simple, because we just choose, we just take those values which are there, which is plus 2 and minus 5, right? So the last one, which is 3, the last one, which is 3, guys, this one don't worry about it for completing the square. X minus n, x minus n. So whenever you are given an equation like this and they want you to calculate the coordinates of the turning points, the first thing that you're going to do, guys, is to multiply everything that you see there. Remove those brackets. How? Let's say you are given y is equals to 1 into x minus 2 and also x plus 4. Let's say you are given an equation like this and you are requested to calculate the coordinates of the turning points. So if you are given an equation like this, the first thing that you do, you just remove the brackets. How do you remove the brackets? Obviously by FOILing out, or the FOIL method. X multiplied by x, whereby it's going to give us x squared. Therefore x multiplied by 4 is going to give us plus 4x minus 2 multiplied by x is going to give us negative 2x. Therefore negative 2 plus multiplied by 4 is going to give us negative 8. We know that negative multiplied by positive is what? It's negative. Like these things, guys. Let me give you something. Let me write them here. We know that negative multiplied by negative is equals to positive, and negative multiplied by positive is equals to what? Negative, and positive multiplied by negative is equals to what? Negative, and then positive obviously multiplied by positive is equals to positive, meaning whenever you have two negatives, your final answer is going to be positive, your final sign. And whenever you have different signs, which is negative and positive here, meaning your final sign is going to be negative. And also you can see here, we have different signs, we see which is positive and negative. Therefore, our final sign is going to be negative. Now we have positive and positive, therefore our final answer is going to be positive, right? Therefore, now let's continue. We're going to have x squared plus 2x x squared plus 2x minus 8x minus 8. So now you can see that this format is for the first formula, which is ax squared plus bx plus c. So you can now do what? Calculate the turning points, right? So we are done with the turning points. So now we are going to talk about the axis of symmetry. So I'm going to erase here. I'm going to erase here. Wait, guys. Okay, guys, we can now continue. Remember, we're talking about the turning points. So now, like I said, we are done with the turning points. We are going to do or talk about the axis of symmetry. The axis of symmetry. Yeah, I hope the spelling is correct. Okay, the axis of symmetry of what? Of parabola function, right? For the first equation, okay, first thing, what is the axis of symmetry? Whenever they talk about the axis of symmetry, they talk about it's a parabola. Okay, sorry guys. Whenever they talk about the axis of symmetry, right? Whenever they talk about the axis of symmetry, just know that they want you to calculate the x coordinate of the turning point, right? Let me repeat it again. Whenever they say write down the axis, the x value of the axis of symmetry, they want you to calculate the x coordinate of the turning point, or they want you to just write down the x coordinate of the turning point, right? So meaning axis of symmetry is what? Is the x coordinate. Oh yes, we did talk about it. Is the x coordinate of the of the turning point, right? So like we said, we're going to do from 1 to 2 and 3 now. For the first example, let's say we're given y is equals to x squared plus 4x minus 1. It was minus 1, right guys? Okay, want us to use this example. So whenever you're given an equation in this format and you are asked to write down the axis of symmetry, remember that the axis of symmetry is the x coordinate of the turning point, meaning our x, we know that whenever we calculate the x coordinate of the turning point is what? Its x is equals to minus b all over 2a whenever we have this format, right? Therefore, for number 2, okay, we can calculate it if you want. Therefore, it's going to be minus, what is b? We know that b is 4 all over 2. What is a? It's 1. Our final answer is negative 2. Meaning our axis of symmetry is equals to x is equals to negative 2, which is the x coordinate of the turning point. If you can check the first example whereby we're calculating the turning points, right? And then you are done. So if you are given an equation in this format, which is y is equals to now let's change the field. Let's say x is equals to plus 5 squared minus 4. So therefore, remember guys, this format, like I said, is whenever you have completed the square, then you're going to have something like this, right? So we know that P, which is here, P, it represents what? We know that P represents the x coordinate of the turning point, right? And remember from the axis of symmetry, we said the axis of symmetry is the x coordinate of the turning point. So meaning our x, remember whenever it's plus 5 here and then it's going to change the sign, meaning our x value is going to be negative 5. Therefore, this is the axis of symmetry of this equation. And then you are done. We are done now with the axis of symmetry of the turning point. Now let's talk about